In this video, we're going to look at factoring algebraic expressions. Now, factoring algebraic expressions is the reverse process of the distributive property. In other words, we're going to take a trinomial and we're going to create two sets of binomials so that when you use the distributive property, you end up with that trinomial. How this works is you're going to think about what terms, when multiplied together, get x squared. Now those terms will go into the first parts of the binomial. I'm thinking to myself, x times x. Then you're going to think to yourself, what two terms multiply together equal 15? Now there are a couple of terms that can be multiplied together to get 15. We have 1 and 15, 3 and 5, but which one do you choose? Well, that comes from the middle term, because that middle term is going to give us the specific criteria for it to work. What this middle term is, the adding of the two inside. When I multiply this and these two, it's going to add up to that 8x. So whatever number I put here has to add up to 8. 1 plus 15 is 16. 3 plus 5 is 8. I am looking for the two factors that add up to 8. That means I'm going to use the 3 and the 5. I will put the 3 and the 5 in those last two terms. Now they do need to be addition because I want to multiply together to equal positive 15 and add together to equal positive 8, which leads me to the two binomials of x plus 3 times x plus 5. And you can check to make sure this works by using the distributive property. Here is another problem. 2x squared plus 20x plus 32. One thing to consider before you begin putting these into two sets of binomials is to see if there is any common factor of all three. If there is something that you can divide all three terms by, you will place that in front of the two sets of parentheses. I notice that I can divide everything by 2. So once I do that division, I'm going to end up with x squared plus 10x plus 16. Once that has been divided out, you're going to keep that 2 in front, and you're going to continue with the factoring process of placing the two sets of parentheses. And now I'm going to go through, okay, what two numbers multiply to equal x squared, or what two terms going to be x times x. And then I'm looking for factors of 16, 1, 16, 2, 8, 4, and 4. And I want them to add up to 10. So let's add these up. 17, 10, and 8. And the pair that fits what I'm looking for is the 2 and 8. So I place the 2 and the 8 in the last parts of the binomial. Do they need to be positive or do they need to be negative? Well, that is determined by, this has to be multiplied to get positive 16, but added to get a positive 10. That tells me both of them need to be positive. I can always check my answer by using the distributive property. When you distribute, you'll get the x squared plus 10x plus 16, but don't forget about distributing the 2 through all of that to end up with the original problem. Here is another example, 3xy squared minus 18xy plus 27x. I want to look for anything that can be divided by all three terms first. And I see that all three of them can be divided by 3. But I also see that all three of them have a common x. So that means that I can divide all three parts by 3x, leaving the trinomial to be y squared minus 6y plus 9. Now we keep that 3x in front, and we're still going to do 2 sets of parentheses. And I'm thinking about 2 numbers that multiply to get y squared, or 2 terms, in this case y times y. And then I need 2 factors that multiply to get 9. So 1 and 9 work, 3 and 3 also work, but I need them to add up to a -6. Now here, I know that when they multiply, they have to be a +9, but add together to get -6. That must mean both of my factors have to be negative. I'm going to put negatives here. And now let's add those together. I get -10 for my first try, and then I get -6 for my second try. The 2 factors I want to use are the -3 and the -3. I'm going to place that in the binomials, and now I have my factored form. Again, you can check by distributing.